Now we're going to take a look at solving log equations. Our first log equation, we have natural log of x minus natural log of 4 equals 0. So what I'm going to do is, actually there's a couple of options on this one. You could use properties to condense this to a single log and then use the curly law to undo it and put it in exponential form. The method of solving that jumped out at me was to add the natural log of 4 to both sides and use the 1-to-1 property of logs. So if you get natural log of x equals natural log of 4, those natural logs can kind of cancel each other out, and what you're taking the log of must be equal to each other. So this one is a little bit faster than the other method, but the other one definitely works as well. So now we are going to check our answer. These are log functions, and there is a restricted domain with log functions. The domain is that the x value, or what you're taking the log of, must be greater than 0. So if we put 4 back in for x, we get the natural log of 4 minus the natural log of 4 equals 0, and that does make sense. Our next equation, we're going to start by dividing both sides by 2. We want to isolate the log, so we have log base 5 of 3x equals 2. And once you isolate the log, if you can't get a log equals a log to use that 1-to-1 power, you can use the curly law and put it into exponential form. And then you'll have your answer equaling that 3x in this case. So we have 5 to the second power equals 3x. And of course, for most of you, you might want to just jump to evaluating 5 squared, which is 25. Save yourselves a step. And solving for x, we're going to divide both sides by 3. So we get x equals 25 thirds. Checking our answer again, especially since it's a log function, if we put 25 thirds in for x, 3 times 25 thirds, we would cancel, we'd get 25. Log base 5 of 25 is 2. 2 times 2 is 4, so that one does check out. Now we're going to take a look at our last equation, our last log equation on this page, and this one involves some fractions. So follow me closely on this one. We're going to start by putting this into exponential form. Even though the variable is already equals x, we just have to evaluate the log. We think easier in exponentials because we've been thinking in exponentials a lot longer than we've been thinking in logs. So for most of you, putting it into exponential form is the way to go. So we've got that base 2/5 to the x power equals 25/4. Now when we've got exponential form, what our goal is going to be is to rewrite both of these with the same base so that we can solve for x, set those exponents equal to each other. Hopefully you recognize that 25 is 5 squared and 4 is 2 squared. So I can rewrite 25/4 as 5/2 squared. So now we have a couple of options. We've got 2/5 as a base, and we've got 5/2 as a base. So if I flip my 2/5, move the 5 to the numerator and the 2 to the denominator, that would be to the -1 power, and then multiply it by the power it's already got on x. Remember, when you flip a fraction, or when you flip the base of an exponential, the exponent becomes negative. Or if the exponent's already negative and you flip it, the exponent will become positive. So remember that rule. It's really helpful for solving equations such as this one. So now we've got the same base, so we're going to set those exponents equal to each other. Negative x equals 2, dividing both sides by -1, we get x equals -2. Now we got a negative answer for this one, so we're going to check our answer. It's not what we're taking the log of, it's the answer of the log. And remember, the answer or the range of a log is all real numbers. So in this case, our answer does make sense.